Hello everybody. Here is your new lesson on 8.4 graphing rational functions. This is very similar to the last lesson, although these functions that we're going to do on the second day are definitely more complicated. So you'll see as we move along. So 8.4 graphing rational functions. Put these notes into your notebook and practice. So first of all, every function that has an x on the bottom, if you look at all of these examples here, get my pen out, all three of these examples, they have x's in the bottom of a equation. So anytime you have an x in the bottom, something weird is going to happen. So it's possibly going to be a whole or an asymptote, a vertical asymptote. So the reason why is if you ever had a fraction that looked like this, 3/0. If you type that into your calculator, 3 divided by 0, you're going to get something that's undefined. When you get undefined pieces, the graph doesn't exist there. So it's possible that your graph will be clipping along and then all of a sudden there might be a gap in it, and that might be just a hole, and then it continues on after that. That's what a hole looks like. The other thing is it might have a vertical asymptote, and your graph might kind of butt up against that asymptote and go up forever, and then on the other side it'll pick it up and then kind of come down forever. So they're all different, and since we're kind of not face to face every single day, I'm going to try to make this as easy as possible. So the way to find vertical asymptotes is to set the denominator equal to 0. The problem with that is when you set the denominator equal to 0, sometimes the denominator is not factored beautifully like it is here. If this wasn't factored, and let me FOIL this out, if I FOILed it out, I'd get x squared plus 2x minus 3. So if you did all the FOIL, first outers, inners, last, this is what it would have started as. So if it started as this on the bottom, you always need to get your bottom into factored form. I put all these in factored form to kind of make your life a little easier to start with. So if you don't have to write these problems down, this is just teaching moment. The only thing you're going to have to really write down is any notes you have. If you want to write this purple part down, that's a good idea. You don't have to put these practice problems because they're not example problems. But if this denominator here, x squared plus 2x minus 3 wasn't factored, you need to either do split the middle or you need to do your FOIL guess and check factoring. But I left them factored because I wanted to go very quickly. So if the denominator equals 0, you need to solve. So if I take these two factors and set them equal to 0, you'd use what's called the zero product property, which we've already done in class when we did quadratics. And you add 1 to both sides, you get x equals 1. If you substitute a 1 in for x in both of these cases, you're going to get 0 times 4. 0 times 4 is 0. You can't have a 0 on the bottom. And likewise, if you set I'm going to change colors here, the x plus 3 part equal to 0, you get x equals negative 3. So negative 3 plus 3 is 0, and negative 3 minus 1 is 4, and 0 times 4 is going to be 0 if you've worked all that out. So these are your two undefined pieces by looking at the denominator being equal to 0. So what does that mean? Are they holes like this, or are they asymptotes like this? Well, they're always going to be asymptotes unless you have the same cancelable factors. They produce holes. So what do I mean by that? This is an x plus minus 2 on the top. Neither of these are x minus 2. So there's no canceling that can be done. So that means these are both asymptotes. Unlike the second one here. If you look at the second one, you have an x minus 2 in the bottom and an x minus 2 in the top. So your hole on this graph is actually going to be at x equals 2. So wherever that graph is, you're going to have a situation like this. This x equals negative 3. And why am I saying negative 3? Because don't forget, you have to set it equal to 0. And you have to bring the 3 over by subtracting. So the negative 3 is actually going to be an asymptote. This one here, the negative 1, is going to be either an asymptote at a whole. Well, let's look at the top. Oh, the top doesn't seem to have an x plus 1, but it actually does. X squared minus 1 is x minus 1, and x plus 1 if you were to factor it. So if I factored it, I would say, change the color here again. Hey, look at this. The top and the bottom have the same factors. So this is actually going to produce a whole. So this whole slide is about determining the vertical asymptotes, which are undefined pieces in the graph. That's one of the most important parts, and also to delineate if they're wholes. So now this whole slide is going to talk about horizontal asymptotes. Now horizontal asymptotes will look like this. And then your graph will kind of do something like over here and kind of merge into that asymptote, and do something over here and it'll merge into that asymptote. And it all depends on these vertical asymptotes here in the middle, what happens in the middle. But this is what it says in our book. If you looked in our book, it tells you in detail how to find horizontal asymptotes of a rational function. Horizontal asymptotes are very important for calculus. So that's something you're going to look at later too. But there's a very easy way to do it. And that easy way is look at the degree, and degree is the highest exponent on x in both the numerator and the denominator. So if you look at this first one, that x doesn't have an exponent, so it's an exponent of 1. This x here doesn't have an exponent either. That has an exponent of 1. If the degree in the numerator is the same as the degree in the denominator, then you just have to look at the numbers in front. A 2 and a 1. Those are called coefficients. So your horizontal asymptote is going to be y equals 2. What would that look like on a graph? Here's a graph. Here is 2. Here is y equals 2. And that's how you would draw your horizontal asymptote. The far and away most popular one is when the degree in the denominator is larger. The degree, remember, is the highest exponent. The exponent on the top x is 1. The exponent on the bottom x is that 2 right there. So you have a 1 degree and a 2 degree. If the degree in the numerator is less than the degree in the denominator, the horizontal asymptote is always 0. And then if the degree in the numerator, like on this last one, is 2, and the degree in the denominator is 1, if there's a bigger number on the top for degree, what's degree again? The highest exponent. If the degree in the numerator is bigger, then there is no horizontal asymptote. So I'm just going to do these really fast. Degree in the numerator is 1, degree in the denominator is 1. They're tied, so I look at the numbers in front. Negative 2 over 1. Let's look at this one. Degree, highest exponent is a 1 on the x. You never look at the numbers, you just look at the x's. And the highest exponent is 2, so you got a 1 on the top, a 2 on the bottom. If the degree in the denominator is larger, degree in the numerator is less than, then you get y equals 0 for b. And this one here, the degree in the top is larger, so this one has none. Okay, so now what targets you're going to be going through here? So our major learning targets are 4 things. You have to be able to figure out the y-intercept. We've already done that previously. The x-intercept. We've already done that previously. And you have to be able to figure out the horizontal and vertical asymptotes. So this slide is just really quickly, and once again, it's optional to write this down, trying to figure out what the y-intercept and the x-intercept is. Well, I'm going to do the y-intercept in red. Over on this side, you take the x and change it to 0. So you have y equals, you have an x plus 3, but you're going to put a 0 in there. 0 plus 3. Divided by, 0 goes in for x, 0 squared minus 6 times 0 plus 5. Figure it out. Numerator is 3. Denominator is 0 squared, 6 times 0 is 0, 0, 0, 0, plus 5. 5. So you get 3/5. Now don't forget, what did I plug in for x? All ordered pairs are xy. In place of x, for a y-intercept, I put a 0, and my solution is 3/5. Sorry, that 3 is kind of tiny. Now I'm going to change colors here to black to get the x-intercept. The x-intercept, you make the y 0. So I'm going to change this y to 0. By the way, we've done this in every chapter since we started graphing. This is kind of nice because all you care about is the numerator, y. I'm going to show you the long work here, but it actually is going to happen all the time. You can just ignore the denominator. That's the shortcut. But here's the long work. If I multiply the right side by the denominator, it will cancel this. But if I do that on the right, I need to also do it on the left. So I don't even know if I'm going to be able to squeeze this all in here. I think I can. But what's 0 times anything? It's 0. You get 0 equals x plus 3. This will always happen. So then, I'm going to kind of go this way because I'm running out of room. You just bring the 3 over, you get x equals negative 3. So what was my y value? 0. And what's my x value? Whatever I calculated, whatever made the numerator 0. So you're going to see that on my next problem. Okay. Now this problem here, this was my slide from last year when I was recording or when I was teaching in every day. And I wanted to show my students last year that all these graphs look really funky here. I want you to take a look at a couple things. You don't have to write this down, but if you look at my denominator, I factored it. If you look at my numerator, I factored it. Hopefully you remember how to factor. I'll put some videos online if you forgot. But if you look at the denominator, x equals 2 from this factor and x equals negative 2 from this factor give you your vertical asymptotes. That's the 2 and that's the negative 2. Okay, so what about my horizontal asymptotes? Go back to the original. The degree in the top is 2. The degree in the bottom is also 2. When they're tied, you look at the numbers in the very front. They're called leading coefficients. You got a 1 here and a 1 here. 1 divided by 1 is 1, so you get y equals 1. Notice how that's right here. So what do I care about? What's your learning target for this chapter? Learning target number 1 is that you can factor the numerators and denominators. Learning target number 2 is you have this rule memorized for horizontal asymptotes. Learning target number 3 is you have this rule memorized for vertical asymptotes where you take each bottom piece, set it equal to 0. And then the last learning target is to be able to figure out the x-intercepts and y-intercepts, which is old stuff, just probably the most complicated stuff. So when you find x-intercepts, you're going to change y to 0. And when you have y-intercepts, you're going to change x to 0. So when the numerator equals 0, you're going to see, I'm going to go back to this, right? I'm going to change colors here one more time. When the numerator is x plus 4, x minus 3, you're going to get a negative 4, and you're going to get a 3. So that's when your y is 0, and you can just wipe out the bottom and worry about the top. Now, how do you get your x-intercepts? I'm sorry, your y-intercepts? Your y-intercepts are found by substituting all of these zeros here. You see them? Those were all x's, but now they're all zeros. Work the math out. So if you do this, you get 4 times negative 3, which is negative 12. And the bottom is 2 times negative 2, which is negative 4. 12 over 4, negatives cancel, is 3. So you get a y-intercept of 0, 3. Now, last year I required my students to put all these extra points on here to figure out where these branches were. And I'm not going to ask you to do that. We'll kind of maybe explore that through Desmos, but that is one of the harder parts, and I'm going to kind of just wipe that out for 2020 due to the fact that I can't help you. All right. So here's my example that I'm going to go through. This is the one you should copy down with me. So vertical asymptotes. How do you do vertical asymptotes? You set denominator equal to 0. How do you find horizontal asymptotes? You do that, I'm going to call it memorized rule. How do you do x-intercepts? You take the y equal to 0 and solve. And how do you take the y-intercepts? You take the x equal to 0 and solve. So how does that work? Well, let's work with the horizontal asymptotes. First thing I need to do is I need to factor numerator, which is already factored, and factor denominator. Well, denominator, I'm going to do guess and check the way I do. Most of you do this in class. X times x gives me x squared. And what gives me 6? 2 and 3 and 6 and 1, but 2 and 3 is going to add up to negative 1. So I'm going to put a 2 here and a 3 here. And if I put, oh, I forgot my x there. If I put a minus with the 3 and a plus with the 2, it's kind of hard to read with my stylus here, but you're going to see that foiling, you get x squared, you get negative 3x plus 2x is negative x in the middle, and you get negative 6. So that is the correct factoring. So how do you find vertical asymptotes? Take each denominator part and set it equal to 0. And solve. This is the clear one, negative 3. And if I was graphing is going to kind of be optional for you at this point in the class. I would do this. But here, this is a 2. Notice how we have the 2 in the top and the bottom. Since it's in the top and the bottom, my inkling would be x equals negative 2 is an asymptote, but it's actually a whole. Okay, so I'm not going to ask you to find the wholes, but I am going to ask you to find the vertical asymptotes. And if you said x equals negative 2, then that would be a false statement. How do you find these horizontal asymptotes? Well, that's the memorized rule. So if I look at the most powerful parts of the numerator, it's x, not the plus 2. And the most powerful part, or the x with the biggest exponent, is x squared. The 1 is less than 2, the exponents. So that means it's a memorized rule that it's always going to be y equals 0. So I'm going to draw in my horizontal asymptote, y equals 0. Now, how do I find x-intercepts? I'm going to set y equal to 0 and solve. 0 equals x plus 2 over the whole, either factored form or FOILed form, it doesn't matter. But the denominator I can ignore because I would technically multiply it to both sides. So I get x plus 2 equals 0, so x equals negative 2 would normally be my x-intercept, but that's why I want you to keep track of this whole stuff. So it doesn't really exist there, so that's a whole. So actually, there are none for x-intercepts. What about y-intercepts? Well, y-intercepts, all you have to do is take the x and set it equal to 0. So y equals 0 plus 2 over 0 squared minus 0 minus 6. You get 2 over negative 6, which is negative 1/3. So we do have a y-intercept of negative 1/3. So your x was 0 and your y is negative 1/3. So if I was going to graph this, it's going to be really hard on this graph because 0, negative 1/3 is like right there, almost on the origin, but a little bit down. That's how you do it. So that's how you do this problem. So in summary, what am I going to ask you to do? I'm going to ask you to find horizontal asymptotes and vertical asymptotes, x-intercepts and y-intercepts, and that's all. I don't know what this graph really looks like, but my guess is it probably does something like this to go through that point. And I don't know if it's up here or down here. It's either one of these two. I don't know which one, and the only way for me to tell is for me to plug in a value like x equals something way over here. So I would say like x equals negative 4, and if it's up here, then it's this branch. If it's down here, it's this branch. I am not going to expect you to do that. But if you look at the produced on Desmos, this is what it looks like. So notice your x equals negative 3 asymptote, x equals positive 3 asymptote there. It's from your bottom. Notice your y equals 0 because your exponents are 1 and 2, and bigger number, bigger degree is on the bottom. So that's the green line. And then if you look at the branches, here they are. But I also want you to really look right there. Remember that hole we had at -2 because of the canceling factors? So when this baby is graphed, it kind of just keeps graphing and graphing and graphing and graphing till it gets that hole. You pick up your pencil and you continue it on the other side. So you usually signify that through an open circle. So this is the only one that I'm going to actually do with you. Ask you to do is I'm going to ask you to do example 2 and example 3. Example 3 is a little trickier, but do your best. I will have a very detailed solution placed on Canvas that you can download and check to see your work. But all I want you to do for these guys, I put the graphs on there, but you don't have to graph them. But I want you to find horizontal asymptotes, vertical asymptotes, x-intercepts, and y-intercepts. And don't forget, kind of keep track and see if there's any holes, because then that will make these not really true. But these are the things I would test you on right there. That is all. I'm trying to make this section a little simple, and I think horizontal asymptotes are new. We did things like setting the denominator equal to 0 for a couple chapters now, so this actually is old stuff that we did previously, and we've been doing x and y intercepts all year long. So really the only thing that's brand new to you is this looking at the degree and trying to figure out what the horizontal asymptotes are. So do your best on example 2 and example 3. Go back into Canvas, check your answers, and look at all the little notes that I put on there. I put a lot more on there than what you need. As long as you get these 4 items right here, you're going to be fine. Thanks for listening.